All right, welcome everyone. Today is Wednesday, the 30th of July, 2025, and this is the SIG Cloud Provider office hours meeting. SIG Cloud Provider is a sub-project of Kubernetes SIGs, and as such, we follow their meeting guidelines, which can basically be summarized as please treat everyone as you would expect to be treated, or explicitly so, please be kind to each other. And if you have a question or would like to talk, please raise your hand and I will call on you. Uh, so, um, there was, I guess before we get started here, let's give a chance for sub-projects to give an update. So do we have any sub-projects here who would like to give an update? Okay, not seeing any hands going up, so I guess everything is going okay. Although there is one sub-project I would like to talk about, although I'm not a maintainer of it, but I've been getting lots of emails about it. Um, and that is the cloud provider Equinix Metal. Um, so I'm trying to remember. So I opened this issue to kind of ask about the current status of this. And I guess since I did a little research, I should probably link this as well. Um, but it looks like the Equinix Metal platform has been deprecated. Um, and they I reached out to Chris Priateri to talk about this, and he's not working on that stuff anymore, but he sent me this link. And I'll just see if I can remember what Chris is. Yeah, that basically talks about the deprecation. So what I'm curious about though is like I've been getting lots of updates on that repo, and it looks like the tests are failing and things are breaking there. But I think if there's not going to be a future for that platform and the maintainers of that platform, do we need to move towards archiving that repo or move through the deprecation process? And I guess just for the sake
What
of
does that
clarity
mean for the
here,
people who are currently using it?
talking about sunsetting. Yeah, Joel.
I'm just trying to think, what does that mean for the people who are currently using it? Like, obviously, the service will go end of life. Is there?
Hmm.
I don't know Equinix super well, and it's a shame Chris isn't here. Um, but I wonder if there is any reason that that provider is still useful beyond the end of life of the Equinix Metal platform next year.
I mean, I feel like it's going to be useful at least until this time, right? Because presumably people will still be using that platform and putting Kubernetes on it, right? And they may also be upgrading Kubernetes on it as well, which means at some level, since the SIG owns that code, we have to develop a plan about either uh, we're going to continue upgrading the CCM so that it stays current with current versions of Kubernetes, or we need to like announce its deprecation and probably need to maintain it for the next three releases, I think, until. So maybe we need to announce its deprecation anyways, because 3 or 4 releases is going to put us into this June 30th, 2026 timeframe. So maybe this is kind of working itself out for us. Like we probably need to announce a deprecation. Part of my problem here is that I started to look at this and there are these bumps that are backing up in here, right? Like CVE bumps or whatnot. But part of the problem is um, we've got like some problems that need to be solved here. So I think like I guess going back to what we had previously discussed in like even upgrading this Go lint actions is having some, problems. So like I guess I'm trying to remember if Chris had upgraded the owners. I think he did actually. Yeah, so we should be good to go in here and start fixing this if we want to. I guess the question is like, is there anybody out there who wants to look at cloud provider Equinix Metal and like take a look at some of these at least build issues and whatnot, to see if we can start merging these dependency bumps? That would be the minimum I think we need to do.
What if we were to think about the release cadence of Kate's? What would be the last release before that June deadline? Sorry, Justin, did I skip ahead of you?
Yeah, Justin, please.
No, it's fine. That was a great question. I have a slightly tangential question, so let's pursue this, and then I think there's like a topic about like metal in general. So let's pursue Equinix first, and then let's.
Okay, cool.
So my line of thinking here is obviously there's a version SKU that the clients allow, right? So in theory, if we, is it plus or minus 2? Am I right in thinking that?
Thought it got updated to 3, actually.
Yeah, well, check with API machinery, but if we can get it to a point where it's plus or minus however many it needs to be of that final release before that June, at that point, I don't think we need to do anything more with it, right? Like it's in support till that endpoint. Once the platform is deceased, we don't need anything more. So it might be that actually we only need to get it updated to say 134, and then 135 comes out, 136 comes out, Equinix Metal no longer matters, and therefore, because it's compatible with 134, it was compatible all the way to the end.
I think that makes a lot of sense. Okay, so I think like I think the action plan here is we announce the deprecation. Update the repo to fix the broken tests. Merge the dependency bumps. Update Kate's to 1.34 when available. And then freeze it. Does that sound reasonable to everybody here? Does anybody have objections or suggestions to this plan? Let's put it that way. I see Theo's giving a thumbs up. Thank you, Theo. Okay, cool. Well, I guess we'll start putting together some plans about this. I can take an action item to send out an announcement about the deprecation. And then, yeah, we can go from there. All right. Justin, did you want to come back to the wider question about bare metal and whatnot?
Yeah, I mean, that'd be great. Thank you. Yes. I have added some experimental support to COPS for bare metal and IPv6. And there's one oddity. I'll paste a link to the test because we actually wrote up the things. There's one oddity around the taint, and basically the node taints. If you don't you can't pass cloud provider equals external to kubelet, or else it will taint the nodes. And no one will clear the nodes. So you actually need a CCM, right? So there is in the sort of obvious way to do this, there is a need for a CCM that clears the taints. That is, kind of a weird cloud controller, but and therefore it's much easier to just to special case and not pass that particular cloud provider flag at all. But it's kind of a weird edge case where I think I'm trying to think about what we need from it's nice that we have cloud provider Equinix Metal because it is it's more like a cloud provider, but I do think we might need a cloud provider Metal that is sort of generic. And maybe if we had that, like what's left in cloud provider Equinix Metal, right? Presumably just a load balancer, or presumably a load balancer support. But maybe that is sort of a path forwards, is to, identify a subset that is definitely required for a Metal, and then things like Equinix Metal could be a sort of fork of it, or an extension, or a additional controller, or whatever it is, rather than having to create all these cloud provider for various Metal flavors. I don't know if it's a good path, but I wanted to raise it as something interesting that I came across that is relevant to this group in terms of do we need a cloud provider? How should we be thinking about cloud provider for kubelet versus for these node taints, basically?
Yeah. So like, I mean, I know there are other Metal platforms. So I mean, like, first of all, like you could just make a cloud provider for your metal platform that just removes the taint, right? That would be like, and maybe that's kind of the generic one that we need or something that's just kind of like this. If you need an external, if you need to run things in external mode for whatever reason, and you just need a cloud provider that can just, approve the nodes as they come up, here's the baseline for that, right? But at that point, it's like, okay, well, why do you even need a cloud provider? Is it doing anything else aside from clearing the taint? If that's the case, why don't you just run in like, non-external mode? Just run normally so that the nodes just come up normally. Now, if like, and this might be, I see Joe, I see you got your hand up, but if your metal platform has the notion of like node life cycling, then that might be like kind of the basic thing that you would want, is just to be able to tell when the nodes become unhealthy. But then we get into the notion of, okay, is a generic provider going to work in that case, or does your metal platform have some, have some API associated with it? I think in the case of Equinix, there was like something called like Prism Central or something like that. That was like the central server that controlled everything. So there was still like an endpoint that was being hit underneath to kind of do some of these things. But yeah, good questions, Justin. Joel, please. Or maybe that's Nutanix that has Prism Central. Yeah, I'm just misstating everything now. Anyways, go ahead, Joel.
So a couple of thoughts was, well, Cloud Provider External, as far as I'm aware in Kubelet at this point, all it does is set that taint. Is there anything else? And
Not to my
so,
not to my knowledge. Sorry, Joel.
yeah, go ahead. And so like in theory, yeah, you just switch on that. I'm doing a metal deploy. I don't need that. But on the other hand, obviously there's other stuff that the CCMs do, like node initialization. And if you are using something like Metal 3, right, that has a lot of information that you could populate on the node for then distribution and scheduling purposes. But the only way the CCM would be able to do that, I would suspect, is to look at the bare metal host resources that the Metal 3 provider gives you. So I think if we were to say, yeah, there should be a metal cloud provider, it's going to be very tightly coupled to Metal 3 if you happen to be using that, or I don't know, whatever the other alternatives are for that particular project. But I can't actually, I was trying to Google this. I can't see a cloud provider for Metal 3. Or Metal Cube, sorry.
Yeah, I think like, yeah, I don't know. Like, I guess like I need to look at, I would love to look at our cloud provider framework again to see like, do we provide at the base level, do we provide it where you just say, hey, if you compile this project and run it in your cluster, all it will do is like clear node taints for you. Because I feel like we have the cloud provider framework that people use to like, build their cloud providers from. But and this may already be like this, I don't know, but it seems like it would be beneficial if you could just say, well, I can just take kates.io/cloud provider, I can compile it and I'll have a CCM that all it does is just clear the uninitialized taint, right? Now, again, this goes back to the question, why would you need this? Why would you want this or whatever? But it seems like having that as like, at least then you would have a component that could do it if you needed something like that.
Yeah, and I think it's partially about like defining the role, who is responsible for this, and like for these various things. And like Joel, to your point, like in that PR, you can also see that we have to set up the pod siders for IPv6 because we're not using a CNI or. Honestly, I don't. The responsibilities are somewhat unclear about like who should do exactly what, and so I think it would be great to define those things. I also think it would be great to get more testing, right? If we had, as far as I can tell, that Equinix Metal doesn't have tests, right? Doesn't have real tests, but I wasn't entirely sure.
Not in Kubernetes infra, I don't think.
Right. So like we can't just say, oh, well, the tests are green, so we will merge that depend.pr, right? So that is a little awkward. One of the cool things is that with that PR, by the way, is it runs in GitHub Actions in KVM. And there's enough oomph in a GitHub Actions to bring up a very basic cluster. And I think it runs conformance as well. So it's sort of cool. And I think that applies. It's not like we did anything magic in COPS, right? It's just like GitHub Actions has enough oomph to do that now. So that's sort of cool.
Yeah, that's awesome. And, and that like we touching on the testing topic again, which is like, I feel like Don Quixote and the windmills here, but like, yeah, like there is a notion, there is an idea that someday we'll reach a spot where we will have kind of like a generic set of cloud controller tests that each specific cloud provider implementation could like implement. And through that mechanism, we'll be able to have kind of like an outreach to say, okay, here is a way that like, and this is an idea that Walter has said many times, and I love it. You know, you've got the notion of distributions of Kubernetes, right? Like Kubernetes on its own, yeah, you run it on a bunch of like hardware that you own, that's Kubernetes. But as soon as I take Kubernetes and I take the GCP cloud provider and the GCP CSI, drivers, and I put them together, I've now created an opinionated version of Kubernetes that could be viewed as a distribution, right? And this maybe is the GCP distribution, right? This is the bare minimum that you would want to run if you're going to implement Kubernetes on GCP. And so you need to have a cloud controller there. You need to have CSI. There might be CNI requirements, whatever. If we can get to the notion of kind of like understanding that and then start to grow that to say, okay, now we're going to use COPS or cluster API or some project that hasn't even been invented yet as like an interface for deploying clusters. And we start to say, okay, now I can say, I want to start a test. I want to choose a distribution. I want to feed that distribution to whatever my cluster construction pipeline is. And then I get the cluster on the outside of that. And then I run these tests on it that have been built from the distribution specific cloud provider. And I think if we ever get to that point, and I'm hopeful that we can, we'll be able to demonstrate a pathway for people like the Equinix Metals of the world to say, okay, here's how you work with the CNCF to contribute your hardware or give us credits that we can use. And here's how we bundle the distribution. Here's how we put it into Kate's infra. Bam. Now we got tests running on all these different platforms. And that, like, I would love to see us get there. I know it's like we've been talking about this for years, but like, it's probably going to take us a while to get it all implemented. So, yeah.
I think that's a great vision. I think like also there's some stuff in kubetest, like they have pluggable things, right? So there's kubetest
Right.
COPS and all that, but like I'm not happy with how monolithic like COPS is, right? Like we want to get to something more interchangeable. It's a hell of a lot of work. It's an awful lot of work to get to that promised land just for COPS, right? And we don't want it to be just for COPS, right? Like we want it to be for everything. So
right. Because now Kubernetes has grown a lot since the early days. There were in the early days projects like COPS, were crucial, and I think they still are crucial, but they were crucial to being able to deploy Kubernetes in a repeatable manner, right? But now it's like the cluster API project has come so far now, where it's like, okay, COPS is a choice, and it doesn't mean you have to get rid of your COPS if that works, for certain scenarios. But we should be building an interface where we could say this part could be COPS, or it could be cluster API, or it could be something else, right? And that I think that'll really bust the doors open. So. All right, cool. Yeah, good discussion. Anybody else have like questions or comments about this? Okay, JD is saying in the chat, a generic test for cloud provider metal check core Kubernetes features, but results can be flaky due to the hardware storage number. Yeah, definitely. And that can vary case by case. Yeah, absolutely. That would be a difficulty towards like bringing back metal tests into like the Kubernetes, like test infrastructure. And I think that's maybe where things get a little more dicey, but yeah, good point, JD.
Sure. Are we focusing more on creating more of the generic test cases, or or some test cases which can be provided to the developers and they can build on top of it? So that would be helpful for them too. Are we planning to do something like that, or?
Right. Yeah, I'll show you kind of a little bit of both, right? So currently, I realize this is a tangent, but I guess we've got a little bit of time here in our meeting. Currently, the tests in Kubernetes test E to E, I think somewhere in here, if I remember correctly, there is a cloud provider. Yeah, this cloud directory. These are the cloud provider tests, and we've pruned some of them, having to do with just like there were incompatibilities between with the way that we were, you know, when we were extracting the old stuff, we needed to take some of these tests out. But like, you know, so like for example, these node tests, these are like the generic node lifecycle test, right? So the notion here is that you could run this test anywhere. Like right now, this test, like it removes a node and then makes sure to see that the node gets removed once the, you know, the instance is deleted or whatever, right? But in order to run this test, you need to have this special framework implemented that allows you to delete a node, right? This comes from the cloud config. And further, we skip this test if it's not AWS or GCE, because those are the only platforms where we've implemented this delete node. So one of the things that we've been looking at, and I've been working with a colleague at Red Hat who's doing some testing around this or doing some proof of concept work, is like, could we make this part of the test generic? And then could we make this part of the test like an interface function and make this an interface function as well? And then what we would do is, for example, from the cloud provider, and I'll use AWS as an example because they've got a nice testing suite here. But from the cloud provider, for example, then we could interface, we could match the interface here. We could implement how does a node get removed? You know, how does a node get deleted? Currently, if you look in the test here, this goes to some script that's buried in these test files that can actually like call the AWS CLI commands to remove a node. But in the future, what I would envision is there'll be some interface function in here that would allow this test to complete. So in the beginning, it would say, can you do the delete nodes test? An interface function here would say, yes, I can do it. And then here, when it gets to this delete node on cloud provider, which is part of the test here, and I think, yeah, you can see during the test, we try to delete the node on the cloud provider, and then, you know, we see what happens. So when this delete node on cloud provider happens, that function would be supplied here in the cloud provider AWS repo. So each individual cloud provider would be responsible for owning and maintaining the way that the test runs on their platform, but the common test definitions would all be here in Kubernetes. So a developer of a new cloud provider could come here, look at the tests, see what tests, you know, need to be satisfied. And you can tell like the GCP tests, you know, they've got a lot more stuff in here because they, you know, there's more support in these tests historically for GCP as a platform. And so it was easier to integrate these things. But eventually you could imagine all this would be moved out to like, you know, cloud provider GCP. And in the end, you know, that would all come out of this directory then. So we wouldn't have any GCP specific code in the core of the tests. It could all be contained here in the GCP part. And Justin, thank you for updating this to the latest Golang. Appreciate your service here. But like this part would contain the test interface, and this part would contain the actual test. And so what I'm hopeful is that in the future, we'll have a set of tests where it's like we've got the node lifecycle tests, we have route tests, we have service tests, and then within each test, you would have the ability to ask the interface provider. It's like, do you implement the load balancer interface? If you do, then we better run this test. Do you implement the node lifecycle controller? If you do, we better run this test. And so, you know, making it so that we have a common set of tests to build conformity across all the cloud providers, but then also allowing developers to have their own tests inside of their repos that could supplement that. And what I would love to see is I would love to see a future where from our core test infrastructure, we're able to see cloud controller tests running on each specific platform, and then we aggregate the results from those different platforms back to our common like test grid. And we could really see, you know, if there's regressions that are happening, because one of the concerns, as you can see, this is in Kubernetes Cloud Provider GCP. Like technically, this SIG owns that code. And if we look at, you know, if we look here, there's just a couple left in this repository. But you know, technically, like we own these, and so there's a responsibility to keep these working. And for that, we need good tests, and we need to be able to see the signal from those tests. So ultimately, the goal here would be to build these common set of tests, allow each cloud provider to interface with those tests, and then somehow get, work with each provider who wants to donate, to have their platforms sending test results back to our test grid. And then we could really get a view of like when things break and, that kind of stuff. So I guess, I know that was really long-winded, but does that answer your question, JD?
Yeah, of course. Yeah, it was quite insightful. Yeah, everything at one place.
Cool. Thanks. All right. I'm going to move on unless folks have other questions or anything. Okay. So that was the last topic we had for the agenda today. But I think we do have at least one open issue that I know we need to look at. And I guess there are, it looks like a few that have been opened up in the last few weeks. So let me close down some of this. And let's take a look at these. And I'm gonna start with this one first because I know there's been a lot of discussion around this. And since Joel's here, I know Joel, you've been having some discussions back and forth with K-Russ here. But it looks like this is a little controversial. So I don't know, Joel, do you want to talk about this, or should I give some background here?
I can give some background. So OpenStack LBAS wraps F5 load balancers, and it looks like when you add an L5 load balancer to the backend pool, it immediately marks that node as healthy without having first health checked it, which is contrary to what you'd expect on like an AWS or Azure or Google load balancer, where they do health checks outbound and they go and run some checks and then eventually add it to the pool. I've been trying to dig to see if I can find if this is an issue with F5 specifically, or if this is an issue with the abstraction on top. I don't have anything concrete yet, but the person, Kairos, said they were having a call with F5 and would try and give some more detail. Apparently, Nginx suffers the same problem. But yeah, so the idea here was that they would add node label syncing and then filtering based on those node labels to stop specific nodes from being attached to specific load balancers based on the labels on the nodes. And it seems quite heavy, and at the moment potentially only useful in this use case. So it looks like Antonio is pretty against this at the moment. I'm just trying to find out all the details of like, is there a way we can solve this in the OpenStack LBAS so we don't need something exposed at this level, I guess. And if we do need something exposed to this level, is it the right thing just for the OpenStack provider? Is it going to work on other providers? Are there other providers that actually need this as well? And it's not just limited to the one use case. Yeah, that's kind of all the context I have so far.
Thanks, Joel. Appreciate that. Does anybody have questions maybe or comments about this? I think like it seems like we need more research before we can go further with this, but I'm just gonna leave a comment here.
Yeah, I think I'd probably add to that comment that we'd like to see where this suggestion or enhancement could be leveraged beyond just the OpenStack case.
Say that again, Joel, just to make sure I captured it here.
Yeah, no, I think that captures it. Like,
okay. Do we
what
want to triage accept this then?
What's the implication of that?
Well, like we remove the accepted, we remove the needs triage. So like we have looked at it. It doesn't mean that we're accepting it in terms of we will make this change. It just means that we have triaged it. But if you think we're still in the process of triaging it,
I mean, it's definitely a SIG Cloud Provider issue to discuss. So okay. I guess we can accept it as, yes, we think we're the right SIG for this, and we will discuss.
Yeah. Okay, cool. Okay, yeah, this is a complicated issue. Yeah, and yeah, Joel, appreciate you like diving into the details, everything too. And Antonio, if you're listening on the recording or your ears are tingling, appreciate you getting into this as well. Okay. So let's see, nodes that are not ready and which might have a node network unavailable condition are added to the load balancer. So this sounds kind of similar.
Yeah, did I comment on this one? I think this is relevant to a KEP that we implemented. If you scroll down, yeah, that bottom comment there from me. So there was a KEP a couple of years ago now, 3458, about improving load balancer health checks. So they actually check the health of the node's ability to proxy requests to the pods when you're using external traffic policy cluster. We've implemented that in several places. GCP's had it for a long time. AWS and Azure is there behind a flag. It looks like, was this OpenStack as well? Whichever platform it was just hasn't implemented that KEP yet. And if they implemented it, it would actually resolve the issue for them. Yeah, OpenStack. So yeah, I mean, I think the issue here is OpenStack provider needs to have an issue and implement that, and there's nothing needed in the core cloud provider change. And no changes required in the core cloud provider stuff.
Okay, so we think it needs to be implemented in the OpenStack cloud provider.
Yeah.
Um, so do we want to, I guess, do we want to triage not accept this then? Or just maybe ask them to remake the issue in the cloud provider OpenStack?
I think it needs to be transferred or remade and then closed. I guess my question is, how many other providers haven't implemented that KEP? Because until they're all implemented it, people are still going to experience downtime.
Yeah.
And for some context of people around who may not have seen this before, we were seeing 8 to 10 seconds of workload downtime through the load balancers before we implemented this KEP, and when we implemented the KEP, it went to 0. So you actually get correct connection draining, and yeah, load balancer health check work properly, which is very nice. The downtime was during upgrades, sorry.
So I guess this is the tough part. So we're gonna we don't want to accept triage on this, but we want to encourage people to make issues on the individual cloud providers.
Yeah.
So I guess is there actually like a triage, like not accept or something? I don't even know what the command for that would be.
I guess the question is like, yes, this is our SIG. It doesn't need to be triaged somewhere else. I think realistically, we just close it. Is the heart a reaction from the reporter? No, it's
It's meant to
runtime. Yeah, okay.
It's 13th. Okay, that at least gives some time for people to make comments and whatnot. All right, looks like we have a flaky test. This is this reboot. We've seen this problem before. Oh, I guess this is the same one. Okay, I think that's the open stuff for now. Let us look at the periodics to see what's going on there. Ooh, this is not looking good. Okay, this is a SIG node test that is failing. And it looks like some problem has really got in there. I'm not necessarily sure that this is a container runtime black box test. When running a container with a new edge, be able to pull from a private registry with a secret. This might be related to the GCP credential provider, but we would need someone to take a look at this from the GCP side. I think this might be something we need to ask. All right, I'm going to make a comment in the Cloud Provider GCP channel to see if we can get someone there to take a look at this. Looks like it just started. All right. Any other questions or comments before we wrap up the meeting here? All right, well, thank you everyone for coming out, and we'll see you next time.